Okay, good morning, Professor David J. Delosreyes. Okay, it's September 24, 2023. The time is around 4:16 a.m. Okay, my topic for this session will be a new topic, and this will be a continuation of my long video format discussion, and this is on college algebra. We are almost done with college algebra. I think I will have to present one more topic before I will finish the syllabus of college algebra. Okay, let's proceed. The subject matter for this morning will be college algebra, and this will now be lesson number 70. We are running smooth. We are almost done, okay? The title of the topic for this morning will be Example Problems on Rational Roots Theorem. Okay. The last time around, I gave you one example from lesson number 69 after presenting the concepts of the so-called rational roots theorem. So this will now be the finality on the topic rational roots theorem. I will give you two more example problems before maybe I will be giving the last lecture on the college algebra. I will try to look first for a very important topic as a last topic under college algebra. Anyway, I am making some long video format discussions randomly, okay? So if there are some topics which are needed, I will try to lecture on the random topics still on the long video format discussion. Okay, let's proceed. Example number 1. Find all the rational roots of the given polynomial. Polynomial meaning an expression that contains more than two terms, right? Polynomial 2x cubed minus 5x squared minus 3x plus 9, and this should be equal to 0. The highest power of x is actually 3, so we are looking for 3 possible roots, okay? The value of the exponent represents the number of roots for what we are looking for. Okay, let's try to bring out the solution. I will make the coefficient of the highest exponent of x to be equal to 1. So I will try to multiply this by 1/2. Okay, I want to eliminate these two here. So 2x cubed minus 1/2, these two here cancel with it. It will be an x cubed. 5x squared times 1/2, that will be, the coefficient will now be a fraction, a negative 5/2 times x squared. 3x times 1/2, that will be 3/2 times x. And 9 times 1/2 will be 9/2. And 0 times 1/2 will still be 0. Okay? We clear out the coefficient of the highest exponent of x. This is now actually just 1. 1x cubed, or just simply x cubed. It is understood that the coefficient is 1 for the x cubed, right? So in here, from the concept of rational root theorem, the coefficient of the highest exponent of the given variable, we represent that as q, and in here it is 1. And for the designation p under the rational roots theorem, p is actually the pure constant term given on the given polynomial, pure constant term. Because here, there is actually an x over here, and unluckily the power of x is actually 0, but x to the 0 is 1. So 9/2 times 1 will be still 9/2. So to make it better looking, okay, we will just write 9/2. No more x, because x to the 0 is 1. So in here, q is 1 and p is 9/2. Okay? Let's try to bring out the concept of the so-called rational roots theorem. To find for the first possible root, we will divide P and Q. Okay, but before proceeding with the division, we'll try to factor out maybe prime factors of the given P and Q. So if we try to find the factors of 9 over 2, 9 is just 3 and 3. Okay, it could be 9 and 1, right? These are just the possible combinations, 3 and 3 and 9 and 1. And that's for the numerator. And for the denominator, it will just be simply 2 times 1 or just simply 2. Right? For the factor, for the value of Q, it is 1. So the prime factor is just 1. Okay, let's try to take one possible combinations. For the trial value of x, we could take, if we try to take the combination 3 over 2 as the value of P, as a trial value, and the value of Q to be equal to 1. So if we try to take the ratio P over Q, this is just a trial value, okay? You could assume any trial value from the possible factors, right? You could take 9 over 2 if you like, or you could take 1 over 2. There's nothing wrong with it. So this should be the so-called an intelligent guess, right? So what I will do, I will try to take 3 over 2. Okay? So the ratio P over Q now will be 3 over 2 over 1, or P over Q will be 3 over 2. What will be the significance of this 3 over 2 here? The first trial value that we will be using will be 3 over 2. Okay? So it's not it's still a trial and error method, but okay, since we are following the rational roots theorem, we had a procedure on how to find for it. Okay? And it is more what they call this exactly nearer to the correct solution than by just the so-called ordinary trial and error without any basis. Okay, so using synthetic division, the ratio P over Q is 3 halves, right? So we'll put x equal to 3 halves for the meantime. Okay? So how do we know that this x equal to 3 over 2 will satisfy the given equation? We use synthetic division. We rewrite the coefficients of the equation after the elimination of the 2 on the coefficient of x cubed. The coefficient of x cubed is 1. The coefficient of x squared is negative 5 halves. The coefficient of x is negative 3 halves. The pure constant is 9 halves. Okay? We will try x equal to 3 halves. Okay, we will do it like this. We bring down 1. We bring down 1. We put it here. Then we multiply 1 times 3 halves. 1 times 3 halves is 3 halves. We put it here. Then try to take the sum of these. What will be the sum? They are of the same denominator, fraction, right? So it will be the sum of the numerator, negative 5 plus 3, and that will be equal to negative 2. The common denominator is 2, so negative 2 over 2 is actually negative 1. So if we try to take the sum of this, the value is negative 1. Okay? So we multiply again the trial value, 3 halves times negative 1 will be negative 3 halves. So this is a plus and this minus. So 3 halves, positive 3 halves times negative 1 will be negative 3 halves. Then try to take the sum of these. This negative is negative, so we are adding two negative values. Okay? That will be negative 3, all over the common denominator 2. So this will be equal to negative 6 over 2. And that will be negative 3. So meaning to say the sum of these is negative 3. Of course, this is negative 1.5, negative 1.5. That will be negative 3. Okay? Or you want without using the decimal, it is this. Negative 3 over 2, or this will be negative 6 over 2, and that will be negative 3. So the sum of this is negative 3. Then try again to multiply this one by the given trial value. 3 halves times negative 3 will be, okay, it will be negative 9 halves, right? This is plus, right? Try to take the sum of these. This is plus, is minus, they are the same magnitude. So the result will be 0. So if the result is 0, meaning our remainder is 0, the assumed trial value coming from the ratio P over Q is correct. So if x is equal to 3 halves, one of the possible factors is x minus 3 halves, right? Because we equate this to 0, we arrive at this. So if we try to bring it back as a factor, it will be x minus 3 halves, right? So the resulting equation now will be one of the possible factors is x minus 3 halves. It was proven from this because after performing the synthetic division, what comes out as a remainder is actually 0. So what will be next? This is for the coefficient of x squared because we are done with x cubed, right? So this will be the column or row for x squared. This will be the column for x, and this will be the pure constant. This is gone, right? So if we try to bring out the equation for this is 1, this is actually times x squared. This is multiplied by x. This is the pure constant. So the first possible factor is actually, we have computed this x minus 3 halves, right? So this is x minus 3 halves multiplied by x squared minus x minus 3, and this one emanates from d. And d should be equal to 0. Then again, to compute for this one, we computed the value of this. If we equate to 0, x will be 3 halves, right? But for this, we must have to solve for x here by using what type of solution you want. It could be by completing squares or by factoring. I think we could solve this one by factoring. So no, it's not by factoring. Because if we try to place it as simply possible factors of x squared is x and x, right? And possible factors of negative 3 will be a minus 3 and a plus 1. Right? Because x times x is x squared, okay, that's fine. A plus 1 times negative 3 is negative 3, that's fine. Let's try to check the middle term if it is correct. The middle term will be x, 1 times x is x, negative 3 times x will be negative 3x, okay? X minus 3x is actually equal to negative 2x. And this negative 2x is not negative x. So we could not use the so-called solution by factoring, right? So what do? We erase this one. We'll do, we use the quadratic formula. A will be 1, B will be negative 1, and C equal to negative 3. These are the exponents of this quadratic here. A is 1, B should be negative 1, and C will be negative 3. So using the quadratic formula, x now will be negative open quantity, negative b. I put the quantity, this is minus 1, plus or minus the square root of b squared, negative 1 squared, minus 4 times 1, the value of c is actually negative 3, all over 2 times 1. Okay? 1 squared is 1, 4 times 3 is 12, but this is minus and this is minus, so it will not be plus, okay? So the value of the terms inside is not a negative value, it's a positive value. So 12 plus 1 is actually 13. Okay? So this is minus, minus, okay? This should now be plus. So x now will be 1 plus or minus the square root of 13 over 2. Unluckily, the roots here is not rational. Not rational meaning it is not exact. They are not integer. So the rational roots of the given cubic equation is just x equal to 3 halves. That will be our answer. And the other two roots, okay, we have computed for it, right? But unluckily, they were not rational, they were irrational, okay? So the next two values will be 1, using the positive sign, 1 plus square root of 13 over 2. And the second one will be 1 minus square root of 13 over 2. This is still an answer, but we designate it as irrational. And the first value x equal to 3 halves are rational. It is a fraction, but the definition of irrational is that the numerator and denominator should be whole numbers, okay? So they are both whole, so we consider it as rational. Okay, that's example number 1. Example number 2, I will give you a simpler one. It's still the same problem. Find the rational roots of the given, still cubic equation, x cubed plus 3x squared minus x minus 3 equal to 0. Okay? Solution. Since the coefficient of the highest power of x is now 1, we don't have to divide the given polynomial by a certain value. It is 1 already, right? Unlike in the first one, it was originally 2, right? So to remove this 2, we multiply all the terms by 1 up. In here, there's no problem. So q here will be 1 and p will be equal to negative 3. Q is actually the coefficient of the highest power of x. This is actually 1x cubed. So I place it here, q is 1. If this is 1, it is understood that it is 1, we don't have to write it, right? But if you're a mathematician, you see it like that, it is understood that the coefficient of x cubed is 1. So q is 1, p is negative 3. Under the rational roots theorem, right? To get the first real value, we will divide the ratio p over q. Okay? No more factoring because this is a single value, right? It will be negative 3 over 1, or that will be negative 3. Meaning to say, if the ratio p over q is negative 3, the first value of x is equal to negative 3. Okay? And we check the validity of this by using synthetic division, right? So if we put x equal to negative 3, then we bring out the coefficients of this. The coefficient of x cubed is 1, the coefficient of x squared is 3, the coefficient of x is negative 1, and the pure constant is negative 3. We'll do it like this, okay? Am I still on camera? We bring down 1, right? Actually, that's the coefficient of x squared. Okay? So we bring down 1. 1 times negative 3 will be negative 3. 3 plus open quantity negative 3, it will be 0. This is plus, is minus, same magnitude, this will be 0. So 0 times negative 3 will be 0. We put it here. You take the sum of this. Negative 1 plus 0, it will be negative 1. Right? Negative 1 times negative 3, that will be positive 3. So we put positive 3 over here. So negative 3 plus 3, it will be 0. So the remainder here is 0. And what's the significance of the 0 here? The significance of the 0 here, the first real value x equal to negative 3 was a real root, right? So if we try to bring out now the equation, okay, the first factor is actually x plus 3. Because x here is equal to negative 3, originally it came from x plus 3 is a factor. So x plus 3 is a factor. So the resulting cubic equation now can be written as the quantity x plus 3. What will be next? This is the column for x squared. This is the column for x. And this is the pure constant. So if we try to write the other part of the polynomial, okay, it will be 1 times x squared will be x squared, 0 times x will be 0, nothing to write, and negative 1 will just be simply negative 1, close quantity, and this should be equal to 0. So this one here emanates from this. because this is 1, this is 0, this is negative 1. This is gone because the coefficient of x is 0. So it will just be simply a combination of x squared and pure constant, and this is x squared minus 1 plus quantity equal to 0. Okay? So factoring out the resulting quadratic equation, try to factor out if it is factorable. You can just by inspection, by completing squares, or by using the quadratic formula. It depends on you. By inspection, we could do this by inspection, right? This is the product of a binomial which are opposite with each other. So x plus 3, okay, and the possible factors of x. Actually, this quadratic here, it got no middle term. So the resulting factor will just be simply x plus 1 times x minus 1. X times x is actually x squared. Negative 1 times negative 1 will be, a plus 1 times a negative 1 will be a negative 1, right? And the middle term is actually 1 times x is x, and negative 1 times x will be negative x. So actually there is no middle term. The middle term is 0. This is the first term, this is the pure constant. So the possible binomial, what you call this, factor of this will be the quantity x plus 1 times x minus 1. Okay? And as a rule in algebra, equate its factor to 0 to solve for x. So x plus 3 equal to 0, the first value of x will be negative 3, the first real value. Right? Next value, x plus 1 will be equal to 0. After the transposition, x will be negative 1. Third one, x minus 1 equal to 0, right? After the transposition, x will be equal to 1. So this will be our answers. We got 3 answers here, and they are all rational. Rational. Right? Why rational? They are all exact. Okay? Okay, that's it, guys. That's the 2 last examples under the rational root theorem. So, this is Professor David J. De Los Reyes. Good morning from Los Angeles.